Okay, for lung SBRT or SBRT in general, I usually like to start with a few contours before optimizing. So I always have this D2cm, which is the body minus the PTV plus 2cm. So there's a 2cm gap around our PTV. Okay, and the reason is usually you're going to look at the dose 2cm away from your PTV in order to evaluate the quality of your plan. Okay, so this is a structure that's everything 2cm away from your PTV. All right. Next, I actually create a ring that's 2cm away. So this ring is 2cm away and 2cm thick. I create this ring because it's a much smaller structure than this D2cm structure. So it'll be a lot more useful for us in the optimizer. We'll be able to push on that dose 2cm away from our PTV a lot better with this ring versus this D2cm structure. Okay, so I create that ring, and I call it ring 50 because at worst case, I want a max dose to this ring of 50% of our dose. Ideally, a lot less though. Okay, and then I create a PTV minus GTV. All right, and we're going to use this in the optimizer. Okay, so since we have those structures made, we can go ahead and create our plan. Usually for SBRT, you're treating a high dose per day, right? So you're going to want to use flattening filter free energy if you have it, just because the dose rate will be higher. So in this case, we're going to use 6x FFF. Dose rate of 1400 is fine. I'm going to use my arc geometry tool to create 2 half rotations around our PTV, but instead of leaving our margin as the default of 0.5, I'm actually going to shrink that down to 0.1. The reason is the whole idea behind SBRT, our goal is to get as fast a fall off as we can. Okay, and so I'm just going to shrink that margin and force it to be a little tighter around our PTV, right? Next, I'm going to come in my fields. So our prescription that we're going to use today is 1000 centigrade times 5 fractions. So since we're using 1000 centigrade per day, our MUs are going to probably be higher. And most of the time, there's a limit set on the technique of arc. So we're going to change it to SRS arc. So that just ups that MU limit. Okay, so we're going to change both of our fields to SRS arc. And those limits can change, clinic to clinic. For example, my main clinic, we have that MU capped at 1500 for arc, but SRS arc, that limit is, I think, 3000 or something like that, something much higher. Okay, so we got our 2 arcs. They're half arcs. Usually for SBRT, I'm using half arcs. That tends to work out fine. What I like to do though is I like to kick the couch. So if I feel like I can do couch kicks, I'm gonna do it. And most of the time I feel like we can. So in this case, I'm definitely gonna do it. We'll do 10 and 350. And what that does is it helps spread out the dose. So we're trying to spread out our low dose so that we can get really, really tight isotose lines of our higher doses areas, right? So remember, we're treating 1000 centigrade a day, right? That's much higher than we normally are. We want to treat basically as little of the body as we can with that high dose. We want it really focused on just our target, right? So if we kick the couch, we're now entering on 2 different planes, and it's going to help spread that dose out. We're going to have really good control over our high dose areas, right? So I always try to kick the couch if I think I can. The more posterior and the more lateral your target is, the more of a couch kick you can do, just because you'll have more clearance, right? It's when it gets anterior and medial that you have to worry a little bit about your clearance. And you got to think about things like the arms and stuff like that, you know. But usually, especially for lungs, I feel like you can get away with 10 degrees in both directions. If I'm nervous, I might shrink it down to 7 or 8 degrees or something like that. But 10 degrees is what I'm trying to shoot for. The smaller the volume is, the more those couch kicks are going to help you out. The larger the volume, the less impact they'll have. But no matter what, they always have a positive impact. All right, prescription 1,000 times 5. Make sure my optimizer is set to PO. Okay, so to start, SBRTs, I start them a little different than I start my conventional plans. All right, so first let's bump this NTO up to 150. Again, we're really trying to crank on those low isodose lines, get them as tight and as conformal around our target as possible. So I'm gonna bump that up to 150. I'm gonna actually use my PTV minus GTV, and I'm using it kind of like a ring, but it's a ring inside our PTV. So if you look at this, at the very edge of our PTV, I want 5,000, right? So I'm gonna put a min of 5,000 on there because I want that 5,000 line to be perfectly right around the edge of our PTV. And for these, my priority I usually set to 75 for my target. So again, SBRT I do a little different than my conventional plans. And then the upper, I kind of look how thick, what type of margin the physician used on their GTV, all right? And I kind of gauge what I want to put my upper on. But basically, I'm trying to force the hotspot to go inside of the GTV, okay? And kind of force it into the middle of our target. So I don't know, let's do 6,000. All right, 75. And then on our GTV, this middle part, whatever I put as my upper on my PTV, so in this case 6,000, I'm going to put it as my lower on my GTV. I'm just kind of telling it I want my 5,000 line on the edge of my PTV, I want my 6,000 line on the edge of my GTV, and it can go even higher and even hotter inside of my GTV. All right, so then 0, I don't know, usually I do 7,000, but the higher you allow this hotspot to go, the more you'll be able to, again, crank on that NTO, crank on your ring, and really get that dose fall off to be as tight and fast as possible. All right, so basically with what we're doing is we're allowing a hotspot in order to get faster fall off, right? If you remember from maybe your physics class, you need to allow that hotspot in order to allow it to fall off really quickly outside of your target. So the higher that you let that hotspot go, the quicker fall off you'll get. The more you restrict that hotspot, the more you will hinder your ability to fall off quickly. Having said that, you can still fall off pretty quickly, even if you do kind of restrict that hotspot. So generally, if we're in the middle of the lung, far away from all other OARs, I'll let it get pretty hot. So per protocol, usually they allow up to 166% hotspot. Okay, so that's pretty hot. I would say most clinics are shooting for maybe in the 140 to 150 range usually. But if our PTV is overlapping with, say, the great vessels or some other OAR, or it's really close to a sensitive OAR, I'm going to restrict that hotspot a little more, maybe 120 or something like that. Okay. If our PTV did overlap with a OAR or was really close, that would affect what I would put in here. So for example, if our PTV overlapped with our heart, Our heart, we're shooting for a max dose of, I think, 5,300, something like that. I can't remember the exact constraint. But because it's overlapping and we're trying to limit the hot spot of that heart, say the heart touches my GTV, for example. I'm not going to put 100 getting 6,000 on the GTV since it touches or is very close to that OAR. Make sense? Maybe I can only put 5,100 in there or something just to make sure the GTV gets covered by at least 100%, right? So what you do here is going to be dependent on, of course, your anatomy and if you're close to an OAR, if you're overlapping with an OAR, something like that. But in this case, we are not close to anything sensitive, or not too close at least. We're not overlapping with anything. We're pretty good to allow a pretty decent hotspot in here, okay? So I'm just telling it, keep that hotspot in the GTV in the center of the target by doing it this way, okay? And then last, I'm going to add my ring. So if I'm going to 5,000, I'm always going to put 0 at 1,900 on this ring, priority of 50. All right, so I bumped these down to 75 just so that they're a little bit closer to the priority of my ring, because that fast fall off is almost equally as important for an SBRT case as coverage. Okay, so we're pushing on all a little bit more equally. And this is how I start, okay? So 150, 75, 50. If your PTV is really small, so usually I say if the PTV is like 15 cc's or less, I'll run it fine. Or if I'm overlapping or really close to an OAR, I'll run it fine just to make sure my resolution of my plan is really good and it turns out really well. If the PTV is bigger, so in this case our PTV is 56 cc's, just to make this go faster, I'm gonna run this at normal. All right, and start. So now the process is pretty similar to how I would plan a regular plan. Oh, so the beam data in this environment is not approved, so we can't use 6FFF, unfortunately. But normally I would. Normally you want to use that flattening filter free beam energy since the dose rate is so much faster. But we don't have that commission, it doesn't look like, or we don't have beam data set up, so I'm going to change these to 6X just so we can run this plan. All right. So now the process is pretty much exactly like how I would plan all my other plans. This is how I start. All right, I'm going to let it get to step 3, and then I'm going to add all my OARs in. So we're going to think about this, though, just a little bit differently. So normally I'm going to add like a constraint on every OAR just to see if I can push, even if it's just a little bit of dose out, right, for a conventional plan. SBRT, you don't want to push too hard unless you really have to, because what you're really pushing on is just conformality and really pushing on those low isodos lines and getting your fall off as quick as possible. So I don't want to start pushing on really hard on all my OARs because it'll start to affect my dose distribution, right? I don't want any streaking in this case. I really just want it to be very conformal and fall off very quickly. That's my priority. So I'm really only going to add constraints on my OARs. Whoops, I missed step 3. But normally I would pause at step 3. Pretend I paused at step 3 right now. And now I'm going to evaluate all my OARs, okay? So chord +5 is very low. I know my chord's going to be safe and okay. Esophagus is low. Great vessels is low. Heart, nothing. Lungs are low. Lungs is one of those things, if you're pushing hard enough on your NTO and hard enough on your rings, you're not going to be able to do much with your lungs. Your lung kind of is what it is. Usually there's a V20 constraint or a mean dose constraint. the way, if you plan this way, there's really, you won't be able to do much with your lungs. Your lungs kind of are what they are. All these OARs look pretty good. Ribs can be one of those tricky ones. Most clinics, I think, prioritize coverage over your rib constraints, but in this case, the ribs are pretty low too. So everything's pretty low. So literally in this case, I probably would not add any more constraints on my OARs. But if you needed to, it's exactly like a conventional plan. If my esophagus was too hot here, I can start putting objectives on it, start cooling that esophagus down, use my uppers. I can use my upper GEUDs. If I was worried about the max dose to my esophagus, I would, I can use a regular upper. I can use an EUD with an alpha value of 40 and start cranking that down. You can push a little bit on your OARs. So if you want to, you can add constraints to your OARs and push. You can see I pushed a little on that esophagus, and it's not really affecting my dose distribution, right? I'm just saying what you don't want to have happen, excuse me, is you don't want to push too hard on OAR unnecessarily and start getting your dose to kind of spill out on the edges of that OAR. All right. So this looks pretty good. If you get to step 3, you start adding your OARs, everything should look good after this step. Again, if something is really close or overlaps, you're going to have to push on those OARs, and maybe you will get your dose distribution to start look a little wacky. But if you got to do it, you got to do it, obviously. I'm just saying if you don't have to, you probably don't want to. You want to focus on this ring and your NTO, basically. If you're struggling to get that quick dose fall off, you can add additional rings. Usually I don't think you need to. Usually if you crank on this ring 50 that I've made here, again, 2 seam away, 2 seam thick, that's enough. I put 0 at 1900. Usually that's enough too, but if not, something that does work really, really well is actually adding GEUDs to your ring, okay? So I'll start with one at 40. We can really crank hard on that, and you'll notice that'll have a big impact, just like UDs always do. We have this big spike, but you can see how quickly we're finding solutions, getting that faster fall off. Sometimes I'll add another one too, just to really crank on all that dose in that ring. We really want to push it in and get that fall off, to happen as quickly as we can. So just a tip. That's about it. So now I am going to let this, play out. Usually you don't have to pause or even touch it, in any of these additional levels. Oh, I take that back. It's always a good idea to pause, especially if you see a big spike. Pause it. It's going to help you out. But we'll just fast forward through this. Okay, guys, it went through intermediate dose, all right? And, just looking at this line and looking at our dose, I'm going to just try to crank on our ring a little bit more. So I'm actually going to back it back up to level 2, and let's just push a little harder on these rings. So I'm going to bump this up to 75, both of these up to 75, and just let it crank on that dose a little bit more, all right? If you notice in level 2, obviously we're not going to put a max dose on the body like we normally do because we're allowing a large hotspot, right? And I'm not even going to worry about this coverage because we'll just normalize to whatever coverage we need. We're meeting all our constraints easy enough. Again, we don't care about that hotspot, right? So I can just normalize to get my coverage. I don't need to worry about that in the optimizer. If we were overlapping with OARs or very close to OARs and I was worried about meeting those constraints, then I would do my standard, extra lower objective 97%, something like that, slightly over prescription dose to get that coverage so that I didn't have to normalize down lower and possibly cause my OARs to go above their objectives. Okay, so again, it just depends on the case, but if you can, if you're not near any of your OARs like this, focus on that quick fall off, conformality. If you are next to OARs, failing objectives, overlapping with OARs, stuff like that, then you're going to treat that and optimize just like you normally would for any other plan. All right, we'll let this calculate here and take a look. Okay, so the first thing I'm going to do is normalize to whatever coverage we want. Usually SBRT, I'm doing something higher than 95, but it really just depends on what coverage you need, right? So let's normalize to pretty good coverage, 97%. Let's go here to dose statistics, ring 50. Worst case, I want it below 50, so we are below 50. Probably could do a little better if we wanted to, but we are below 50. Where is our PTV? Min dose 91, not too bad. Some protocols, some physicians like a min dose 95. Again, if you needed that min dose 95, you would handle it just like any other plan. You got to find that cold spot and contour it out and push on that in the optimizer. If we right click over here on this triangle, we can go to view columns and we can look at our conformity index of our PTV. Conformity index is 1.0. That's pretty good. Most protocols want something less than 1.2, but really 1.2 is very easy. You should never be anywhere near 1.2, in my opinion. Really something right around 1. So we're normalized so that we have 100% covering 97% of our volume, right? So 3% of our volume is cold. Our conformity index is 1.0, so that means the volume of our 100 is exactly the same as the volume of our PTV. So that means we have just a tiny bit of spillage, right? It's a tiny bit outside of our PTV that is covered by prescription dose, but not very much. It's really good. Our conformity is very, very good. Zoom in here. And you just want to kind of look at your dose distribution, right? You want to look at that 100 line and make sure it's conforming nicely to your PTV. From here, if you're unhappy with your coverage or how it's conforming, you can add additional rings. Maybe add a ring right around your PTV with no gap to help control that 100 line. Maybe you have to create a cold spot contour, right, to get all those cold spots and put that in the optimizer. From here, you would treat it exactly like you treat any other plan. If you're failing a constraint or objective, you're just going to push on that in the optimizer in your second run. All right. Last thing, if we look at, let's say, a 20% isodose line, you can see what it looks like here, right? It's fairly compact around our target. That's what we want. If you did not do the couch kicks, you would see that 20 line go all the way to the exterior of the patient. Those arcs would be in the same plane. That dose would just add up from each arc, right? Here we're splitting it up into two different planes, spreading that dose out. So sometime try to do a coplanar plan and then a non-coplanar plan and look at some of these lower isodose lines and compare the two, right? If you do this couch kick, I promise those lower isodose volumes will be smaller than the coplanar plan. Okay, that's it. If you have any questions, please let me know.